So in the coming minutes, I'd like to talk to you about the contributions of IHE Delft to coastal engineering. A lot of these things have been done in collaboration with Deltares, where a couple of us also work part-time. But these developments are things that we invite you to join us in. An important thing has been the Delft 3D morphology development. Originally started when I was still at Delft Hydraulics together with an IHE master student, Charles Lesser. We've done a lot of validation since then, and especially through the work of Mick van der Wegen, my colleague. Delft 3D long-term morphology prediction has become really advanced, and we are able to simulate tidally dominated inlets and estuaries over periods of decades to centuries. The X-Beach storm impact model, which I originated, and that is now becoming a world standard for doing storm impact, dune erosion, overwashing, breaching of barrier islands, those kind of processes. My colleague Rosh Ranasinghe has been developing the probabilistic coastline recession model, PCR, and this is a very cool tool to fully probabilistically estimate the shoreline recession over also a period of decades to a century. And then to have an efficient model to assess the climate change driven coastline changes in cases where your coast is interrupted by inlets, we developed a model called SMIC, which is fast and efficient. Then with my younger colleague Johan Rijns, he is also doing his PhD and working at IHE at the same time, and he's one of the main developers of the wave and morphology components of Delft 3D Flexible Mesh, the new generation, let's say. My colleague Alvaro Semedo is making a strong contribution to the Cowclip Ocean Wave Climate Forecasts Club. This is a consortium of the advanced ocean modelers to develop, to see how the ocean climate will change in the future. I've recently developed a coastline model, shorelines, which I'll show some examples of also, and that I think could become the next generation in flexible shoreline modeling that can handle very complex situations as well. And then we have the world famous Jentje van der Meer, who is the father of many dike and breakwater design methods. I'll show some typical animations and pictures of these contributions. Here's an example of what of the modeling of what happened at a breach in a barrier island of Long Island. PhD Maarten van Ormond, PhD at IHE, works at Deltares, funded by US Geological Survey. And so this is what the inlet looked like after the breaching by Hurricane Sandy. And in this case we show a very advanced simulation using both Delft 3D and X-Beach alternatively, and to simulate 3 years of coastal evolution. And see, this is an extremely dynamic system. We moved from the black dashed line to the red dashed line, which is both the observed coastlines at the beginning of the run and after 3 years. And you see that magically the simulation ends up in a very, very good comparison with data. This is about as advanced as it gets with these medium-term morphodynamic models that both take the average conditions and the storm conditions with the X-Beach. And you have the typical advantages of a flexible mesh are shown here, that you can have these curvilinear stretches where it's useful, and you fill the rest up with triangles, and in this case this way you get a very nice and accurate computational mesh with the refinement where you need it. And here's an example of how the currents, what the currents look like when you run them on this model. With you see the details of the transport and the flow patterns are spectacular. For instance, here these eddies that you see here, and this is really what is needed in these really complex areas, of which you have many in the Mekong Delta, but also on the Central Coast and in the Red River Delta. Climate change impact quantification at a regional scale. This is the scheme of how people like Roshra and Singer do their climate downscaling studies, and go from these climate change scenarios to global climate models, to ensembles, to regional models, and finally apply them on a really local scale with multiple simulations. And one of the things he is worried about is that this model has to be really fast in order to be doable with a probabilistic approach. For that he's developed this probabilistic coastline recession model that is a very fast approach that has been applied in many places in the world, and I don't have time to go into this, but it is relatively simple coastline recession models due to storm, and then a heuristic beach recovery approach, and that is something that runs that you can run 100,000 times in 10 minutes. And with that approach you can really try to predict the probability of flooding or erosion at a certain location, and you can combine that with the damage that would be done to provide a map of the risk in terms of dollars per square meter. And also one of the models that would be useful to use in such an approach is this SMIC model that he published in Nature, and what that shows is that if you're in the area near a tidal inlet, and then without that tidal inlet, this impact of sea level rise would be very limited with only the Brune rule effect. But if you include the fact that a lot of sand would disappear into the tidal inlet, then you get this red line, which is basically indicating that there is a lot of areas that are built up that will be in trouble. About the long-term morphology used with Delft 3D and other two-dimensional models, we have gone to the situation where we have a measured configuration of a tidal estuary, and if we start with a flat bathymetry, we can actually generate topographies that are extremely similar to what is observed here. And this is a case where we did a 110-year hindcast of bottom changes on a scale of plus to minus 25 meters, and you also see an astonishing good agreement. So for tidal inlet systems, we are able with very detailed models to predict the channel configurations and the shoals, and all sorts of other properties of the tidal estuaries. Here's some examples of predictions of climate change on the future wave climate. I won't go into the detail, but it's obvious that if the waves are changing in height or especially in direction, that can have large impacts on coasts like the Vietnamese central coast. There was this sand engine or sand motor that I was talking about, and this is a new coastline model that can simulate these kind of complex developments. So not just small changes of a coastline, but also really radical changes, the merging of this spit to the coast and the further development. That lagoon can break up again later, and so islands can move to the coast. So this is an exciting new development, and an example of comparison of that method with field observations of the coastline change. And finally, the hardcore coastal engineering is still getting plenty of attention. Appraisal, design and testing of breakwaters and coastal structures. Jentje van der Meer is the one who develops these formulas and writes, and he also developed this simulator that can be used to test the strength of dike sections, and even to develop run-up tests. So this is a run-up test. Very exciting stuff. And he also wrote this book on the design and construction of berm breakwaters. So I hope this gave you a bit of an impression of the things we do at IHE. Come do an MSc or PhD at IHE Delft. There will be new Vietnamese scholarships soon available, and for very talented IHE students we can offer top-up funds to raise the living allowance to an easier level compatible with what other students and other scholarships offer. But also we're always looking for opportunities to collaborate, for instance in joint research on climate impacts on deltas, or joint development of online learning modules. Chang will be handing out forms that you can use to fill your name and email if you're interested and indicate your topic of interest. Thank you very much.